All right, let's dive in. Today, we're putting you in the architect's chair. You've got a huge design challenge ahead of you, one that's at the very heart of how our digital world actually connects. So, picture this. You've been given the job of designing a brand new network, completely from scratch. Before you even think about cables or routers, you need a plan, right? A foundational model, a blueprint that's going to guide every single decision you make from here on out.
Now, historically, there have really been two major players for this role. On one side, you have the official, internationally approved standard, a really perfect theoretical model. And on the other side, well, you've got the pragmatic pioneer, the one that just went ahead and won the world with its real-world protocols. So, let's meet our first contender.
This is the OSI model. Now that stands for Open Systems Interconnection. It was designed by the International Standards Organization, and they had this really grand vision for it, to be the one single universal standard for every computer network on the planet.
Its biggest strength is that it is a model first and foremost. Think of it as this beautifully abstract theoretical tool. It was designed for one thing, really, to help us understand how networks should work. It takes every possible network function and neatly separates it into its own logical layer.
And it does this by breaking down the huge complexity of network communication into these 7 distinct, manageable layers. Every layer has a super-specific, well-defined job, from the raw bits flying across a wire at the physical layer, all the way up to the application layer that your web browser is talking to.
Okay, so that's the theory. Now let's look at our second contender. This isn't just a theoretical model. This is the actual foundation of the internet that you and I are using right this second.
You know, unlike the OSI model, which was dreamed up in a committee room before the protocols even existed, TCP/IP was pretty much born in the trenches. The protocols came first, forged in the fires of ARPANET, and the model was just created later to describe how these things already worked in the real world.
So it's a much more condensed 4-layer stack. It's leaner, it's more practical. You'll notice, hey, where are the session and presentation layers? Well, in the TCP/IP world, those functions just get bundled right into the application layer if they're needed. It only includes what's absolutely essential to get the job done.
Okay, so for our big network design project, how do these two blueprints really stack up against each other? It's time to put them head to head.
Now, this is where it gets really interesting, because this reveals a deep, fundamental difference in philosophy. See, the biggest contribution of the OSI model is how it clearly separated what a layer does, its services, from how it does it, its protocols. TCP/IP, since it was just describing stuff that already existed, didn't really make those distinctions. This made OSI a fantastic general model, but it also made TCP/IP way more flexible where it counts, like, say, offering you a choice between reliable and unreliable transport.
So while the OSI model is this elegant, powerful tool for thinking, well, history has a very clear winner when it comes to what we actually use. So why? Why did this carefully designed, internationally backed standard, this blueprint for perfection, fail to take over the world?
The thing is, it wasn't a single silver bullet. The story of OSI's fate is really a classic tale of pragmatism beating perfection. It was sealed by this perfect storm of issues that pretty much doomed it right from the start.
It really came down to 4 key factors: bad timing, technology that was a bit too cumbersome, some really flawed implementations, and yeah, even a little bit of politics. Let's start with what might be the biggest reason of all: timing.
You see, when it comes to tech standards, timing is everything. There's this tiny little window you have to hit, right after the initial research boom, but before the big wave of corporate investment. And OSI, it just completely missed that window. By the time its standards were finalized, universities and developers all over the world had already started building on, using, and pouring money into TCP/IP. That ship had already sailed.
The second problem was the technology itself. That 7-layer model, while it looks great on a whiteboard, was just too complicated in practice. People found that some layers, like session and presentation, were barely used by most applications. In contrast, you had the lean, mean 4-layer TCP/IP stack, which was focused only on what was absolutely necessary.
And that complexity led to some truly terrible early software. Early OSI implementations were notoriously slow, buggy, and just gave the whole thing a bad reputation. At the very same time, a free, high-quality, and super-fast version of TCP/IP was available as part of Berkeley Unix, which was massively popular in universities. So you had this grassroots movement for TCP/IP, while OSI was seen as this clunky thing being pushed by out-of-touch bureaucrats.
So after all that, we're back to our original question. What's the final call for our new network design? Which blueprint do we actually choose?
And this quote just hits the nail on the head. It's not about one being good and the other bad. It's about recognizing that each one has a distinct and incredibly valuable strength. One is a tool for thinking, and the other is a tool for building.
The verdict for our little case study here is crystal clear. When it comes to the actual implementation, the nuts and bolts of our network, we're building on the foundation of TCP/IP. It's the language the rest of the world speaks. It's proven, it's efficient, and it just works. End of story.
But, and this is so important, we don't just throw the OSI model in the trash. We keep it as our mental map. When we're designing something new or trying to figure out why something broke, thinking in those 7 distinct layers is an absolutely invaluable skill for any network pro.
So in the end, you really get the best of both worlds, a proven, real-world set of protocols to build with and a powerful, clear conceptual model to think with. The blueprint has been chosen. Now the only question left is, what will you build?